Hello from me. My name is Pavlos Floratos, and this webinar session is about feature detection in casted parts with the use of machine learning. Since version 22.10, we have the possibility to make a DM library with fasteners and use it to recognize and treat fasteners on other casted parts. So, let's start the session. First of all, what problem are we trying to solve? So the problem here on casted parts is that this kind of files have many fasteners, many embedded clips. And these fasteners, most of the times, are either identical or very similar with each other. And a user, when he has to fix a part like this, he has to go and fix the same embedded clips over and over again. With the functionality that we will see now, someone can make once a DM library with these embedded clips, and he can automate both the recognition and the treatment of the fasteners. So this demo is actually composed out of two parts. On the first part of the demo, we will see, once we have this library ready, how we can utilize to recognize and treat fasteners in our model. And on the second part of the demo, we will see how someone can build such a DM library from scratch. So this here on the screen is my model, and on this case I have already specified a DM path. And my DM looks like this. So if I open the DM browser, I have many clips stored, both the common representation of these clips, which means actually their geometry, and also a mesh representation that I would like to use on them. What is the first step that we need to follow in order to recognize the clips? We should open Feature Manager, go on the parameters, and use the option here, recognize fasteners, and more specifically, recognize embedded clips. And as the tooltip says, this is an option that requires a DM library in order to run. I will press recognize, it will take a few seconds. So what actually is the background of this functionality? The background is that this option invokes an already pre-trained machine learning predictor for clips that we pre-trained in our own data and put it inside ANSA. And this predictor is invoked, and along with the definition of the fastener that exists in the library, it is able to recognize all the similar embedded clips that exist in your model. So let's more seconds in order for the predictor to run. So the recognition has been completed. As you can see, we have recognized automatically all the clips that exists in our file, and we can also see them listed inside Feature Manager. Now that I recognize them, what is the actions that I have over them? Of course, someone could select a clip and through Feature Manager again ask to import representation. So as long as this clip has also a mesh representation that exists in the DM, I am able to import it and place it on the respective position in the model like this. But of course, this is not something that I have to do, let's say, manually for every clip through Feature Manager every time. I can do it in a more automated way through casting. So let me move to the casting function. And on the casting function, on the tab of features, you see here that there is a special category for fasteners. So let me first briefly let me execute casting, because we will need to wait some time. and I will explain this option as long as we wait. So the first category of the options of the fasteners group are about recognition. So the same option that we had in Feature Manager about recognizing fasteners can also be done through casting. But as long as I have already recognized them, I don't need to recognize them again. This is why I didn't use this option. The second option in casting is about the treatment of fasteners. What fasteners treatment means? If I enable it, it means that casting will ignore all the faces that belong to fastener features. This way, casting will produce a result only in the main body of the part, and it will not produce a result on the fasteners. But I am able to also select a meshed representation if it exists in the DM, and this way, first of all, casting will ignore all the fasteners, it will not make a result, and after casting is completed, automatically and massively, all the meshed representation that exists in the library will be imported into the model. So again, let's wait a few more seconds in order for casting to run. Yes. Now casting is ready, let's say, and I see here the result that I got after casting. So this is a very nice result. Casting gave me the result on the main body of the part, and for the clips, an already fixed representation that exists in DM is used. One thing to notice here is that these clips on the current ANSA version are not connected automatically with the main body of the part. It is in our near future plans, probably in version 23.0.0, to have these clips automatically connected with the main body of the part right after casting. So these things will come connected in the future. But on the current version, we don't have this functionality, and what someone should do if he uses this tool is to go and connect them. And we have a dedicated connect function for this. So the user has, first of all, to pick some edges for from the clip, first of all, and then let me pick the edges. Like this, confirm. I will select also the target cells, like this. And with this function, we can easily connect the clips with the rest of the part. But as I told you, this would be automated in the future. Another thing that may be helpful here is that the user can use the inspect function just to check what, let's say, unconnected areas and unconnected clips exist in the model. So I think I saw someone raise the question. As I told you, I will look at the chat after we finish the session and we will answer all your questions there. So let me finish first. You can type the questions now, I will answer them later. So inspect is a function that has a lot of capabilities in checking if our casting result is correct and has many options here. Now, let's say for this case, we don't care about these options. We only care about the option unconnected cells just to see what fasteners we need to connect with the rest of the model. So now, if I just use this option and select everything, I see that I have all the unconnected areas, actually all the clips, marked with red color. So here I can turn off and on the visibility, and I can very easily check if I have, let's say, connect them all or if I have something left. So actually, this is the first part of the demo. This is how we can utilize a library with fasteners. So as long as we have the library, we can automatically recognize the similar clips either through Feature Manager or through casting. And as long as we also have a mesh representation for these clips that exist in the DM, we can manually import it, or even better, automatically import it with this fasteners treatment of option right after casting. And now we will proceed with the second part of the demo, on which we will show how someone can build such a library from scratch. So please let me reopen my example, just to start on a new file. And I will also remove this already complete DM, and I will add a new folder as my DM folder, DM new. Okay. So let me remind you that the process that we will see now, it's something that you need to do only once. So you need to once time to go through your data, make the library, and then you can use it every time you have a new plastic part. And this is something that can save you time. And of course, if you want, you can keep the library updated from time to time. So the first thing that we need to do to build this library is to save in the DM the common representation of the fasteners. And by common representation, we mean the geometry of the fasteners. So in order to save it, we need first to recognize it, or if you want to put it inside Feature Manager, the respective faces of the fasteners, and then to save them in the DM. There is more than one way to do it. So someone, for example, could use the manual edit function, go to the fasteners category, and manually select in the way that he wants the fasteners that he wants, the faces that he wants to add as fasteners. But there is a better way that can help you in this process, and this way is with the function isolate embedded clips. What this function is? This function is also powered by machine learning, and this function opens the same pre-trained machine learning clips detector that exists inside Ansa. The difference is with the previous option is that first of all, this function does not need a library to run. You can run it on a brand new file with no DM. And the second difference, is that it does not work in batch mode. It works, let's say, in a more manual mode, that it recognizes the fasteners based on the current view that you have on your model. So now my clips detector is enabled, and every time you see I do a movement in my screen, every time I move my screen, I will see that I have I see what fasteners have been recognized. And as long as I get, let's say, a nice clear view, you can see that the recognition can be very good. So all the clips are recognized, and maybe there are cases that I get some minor errors, like some faces are missing from a fastener, or we have some extra face on another fastener. But this is not the problem. We can just use this as an initial picking tool, and then we can edit our recognition afterwards. So now, if I press the Create Clip button, all the faces that I see highlighted on the model will automatically be placed inside the Feature Manager. So now let me move my screen. I want to get another view. And again, I will create clip, and I will put also these faces inside Feature Manager. So now I can close the detector. I can change my view to feature. You can see that all these have been marked, and I can also open Feature Manager. I will use the option edit just to check very briefly if I have anything here that needs to be edited. So now For example, I can remove these faces that are not needed. Or maybe I will remove these faces. So as after this, let's say, inspection and add addition of feature is okay, we can just confirm, and through Feature Manager, we can save all of them in the DM. So we can select them all, right mouse button, DM, save in DM. So one thing to notice here is that on the Feature Manager window, I see that I have a total of 21 fasteners, but on the Save in DM window, I'm asked to save only 18. Why this happens? This happens because both in the saving process, but also on the recognition process, let's say we identify which fasteners are unique or which fasteners are very similar, and we don't save them in the DM twice or more. So we recognize the unique instances actually, and we save only one instance of every fastener. And this is good because, first of all, your DM is smaller, and secondly, you have the possibility to recognize similar fastener in future files that are not completely the same with the ones that exist in the DM. So now I will press finish. And after a very short time, all these fasteners will be saved in the DM. Now we see that the save has been completed. We can see that all of the fasteners are saved because we have a green color here on the status column. And we see that also the fasteners got automatically a module ID. What this module ID is? This module ID is the module ID of the part plus a suffix. And if we see fasteners that have the exact same module ID, this means that these fasteners have been marked as identical. So these three instances here are either identical or very, very similar, and only one of them has been saved and in the DM. Now, we saw how we completed the first step of saving the geometry of the fasteners in the DM. What would be the easiest way to build an FE representation and save this FE representation of every fastener in the DM? Again, there is more than one ways to do this. For example, someone could say, okay, I will isolate a fastener or maybe all fasteners, something like this, and I will run casting on this fastener here and take the result and save in the DM. So the issue with this approach is that when casting runs on an open volume, there are cases that it does not make a good result. So there is a chance that on this area here, we will not get a good result. Of course, someone could go and fill it manually in the geometry level, but this is generally a time-consuming process. So we think that the best and the fastest way to build this FE representation is through casting. So you can just open casting like this, and you can run it normally without fasteners treatment. So this checkbox is off, and this means that casting will run as always normally, and it will make a result both in the main body of the part and the fasteners. And casting gives us a very decent first result, and we are able, with a few modifications, to fix the clip in the way that we want it and use the cells that correspond to the clip and save them in the DM. So again, we will have to wait for a brief time in order for casting to run. Okay, casting should finish soon, I think. Okay. And we got our result. And our result looks like this. So casting ran normally. It gives us a result, and we can use this result to save the desired FE representation of the DM. Of course, on the cases that the result is not perfect, we can fix it. So fixing it, it will not be difficult. It just requires a few manual actions. For example, let me try and very fast fix one of them, like this, and like this, and like this, and like this. And maybe also, let's say, apply a reconstruct. And as long as we fix our representation in the way that we want it, we can use it and save it inside the DM. The only safe and the best way to do this step, to save this in the DM, is through a plugin. So for this job, you should not try other ways, other manual ways from Model Browser, for example. You should use this plugin that is called Build Fasteners Library Add FE Representations. And what this plugin does, first of all, this plugin works on fastener features. So it works on fastener features. You have the option here to work on whole database, visible or selected. And you can also select the name of the FE representation that you want to save in DM. As long as you press next, you will see here that you will get a list. And this is a list with all the fasteners that we have selected. And to be more precise, it's not a list with all fasteners, it's a list with all the unique fasteners. So if I get only one representation, in case that some fasteners are identical. And in the same time, this tool created some respective sets in the database browser for these fasteners. What we have to do is through this tool, we should go and manually edit the contents of this set and place inside the set the cells that, let's say, correspond to this fastener, like this. So, for example, I can go on some other fastener, for example, maybe this one, right mouse click, edit set contents, and put the contents of this fastener in the respective set. So, when I edit the contents of the set and I put some cells in it, you will see that I get a tick mark here. So this means that this set is filled with contents. So since version 22.1.0, we automated this step. So the tool does not start with empty sets. It automatically gathers and finds the elements that correspond to every fastener. And the user, the only thing that has to do is to review it, accept it, or maybe do a few modifications. This is for version 22.1.2. But in the current version, you have to fill this set, and after your selection is completed, you need to press the button Save. As long as you press Save, you will get a report here that will say that two fasteners were successfully saved in the library, and the rest of them, 16, were omitted because their set was empty. Now, if I go and open my DM browser again, I will see here that I have common representations and also the mesh representation of two fasteners here in the library. And if I open my plugin again, just to check it, I will see that I have also a second column here that informs me which FE representation of the fastener already exists in the DM. And if I want to change it, to edit it in the DM, I can first of all edit the contents of the set, and secondly use the override option here and override the definition that exists in the DM. So actually this was the second part of the demo, on which we demonstrated how we can build this library from scratch. So let me do, let's say, a brief sum up of the functionality. First of all, this process is a process that you need to make only once. So you build a library once, you use it every time on every new file, and you save time. The first thing that we need to do is to put inside Feature Manager all this geometry of the fasteners. We can use the isolate embedded clips predictor to help us with this selection. After this, we open Feature Manager, we select everything, and we save it in the DM. Afterwards, we run casting normally without any fastener treatment on the whole file, so just to get a result everywhere. We are able, of course, to fix the result in the cases if the result is not good. We can fix the result and make it as good as we want. And finally, through this dedicated plugin, Build Fasteners Library Add-a-Fee representations, we are able to save these mesh representations in the DM. So actually the demo has been completed. Before we move on the Q&A session, let me also share a few more information with you. So first of all, this ML recognition functionality in ANSA is an add-on feature. So in order to use it, you will need to have some special credits on your license for this add-on feature. And you also need to have to download and install an ML toolkit with machine learning libraries from our website. You can download it, place it on your machine or on a shared location or your organization. And if you have both the extra add-on credits and the libraries, you will be able to use the functionality. From everything that we currently demonstrated, the functions, the ANSA functions that require this machine learning algorithms and functionality is, first of all, the isolate embedded clips that recognizes in manual mode from our screen the embedded clips from the current view. And secondly, the option that exists in Feature Manager and in casting, which is fasteners, recognize fasteners, and recognize embedded clips. This option is automated. It requires a library and recognizes the fasteners on your whole model. And a final information is that I mentioned that both of these tools, the isolate embedded clips and the recognition, use a pre-trained predictor that exists inside ANSA. As a future step, you have the possibility to train your own clips predictor from your own data. So let's say that your data is more complex, more weird shaped, and you see that the pre-trained predictor fails to find some of them. We give you the possibility through Convos to train your own clips predictor from your own specific data, and then you can put it inside ANSA, and both of these functions, both the manual, let's say, one, and the one that works in batch mode, will use your own pre-trained predictor. So this was everything from my side. Thank you a lot for your attention.